Okay, so let's look at our water supply. First, we'll take a look at it on the global level, and then we can look at it on the household level as well. So, importantly to understand is that as the population increases, we're using water at almost twice the rate as the population grows. So as we add more people, we're almost doubling water usage. Um, and so groundwater mining, the extraction of water from these aquifers is starting to drain them. We're not recharging them fast enough. And again, water use isn't evenly distributed either. So notice here, this is global declines in groundwater. Up in North China, it's a little less southern plains, which includes the High Plains aquifer. But over here, for example, in northwestern India, we're seeing huge growth in population. A lot of this is farmers, for example, that use more water for irrigation. And as their cities grow as well, adding more population to the cities, getting much, much more water usage. So again, it's not even. A lot of it just has to do with those areas that are expanding in population the greatest. In the United States, again, even in the U.S., it's unevenly distributed across space, and especially seasons. Um, Unfortunately for us, basically most of the population, about 2/3 of the population, and most of the crops, they're located south of where the most precipitation happens, which is further north, of course. So to make up for that, we've constructed the aqueducts and the canals and reservoirs that move water from the areas that have a surplus to those areas that have a deficit. So that's why you want to watch that video and the weekly module on moving water across California. So for the U.S. as a whole, here's kind of how it works. On the average, our precipitation is about that, billions gallons. We have the actual evapotranspiration, what we use in terms of irrigation, and also for forests and other vegetation, and then what goes back into the atmosphere. This, the surplus that's left after this, available for stream flow and groundwater recharge or withdrawn for human use, goes into streams. Some of it's withdrawn out of that. Generation of power is very high, irrigation, domestic commercial use, industry and mining, and then what's consumed, meaning that that's not available for additional use. In-stream uses, wastewater, runoff to ocean, and then all this goes back into the ocean. And if you add it all together, it kind of equals that again. So out of the precipitation, again, we get what we use is very small amount. It's just this, so out of all that, humans use a very, very small percentage of that. In a home, this is very typical of our home water use. Much of it is the toilet. And again, here in California, they pass laws to dramatically decrease the amount of water that toilets use. In schools and so forth, they've gone from, especially in the men's restrooms, they've gone to these urinals that are non-flush. And, that's dramatically decreased. This is 99, so some of this has changed, of course. But in general, it's still fairly accurate. If you use a washer to wash your clothes, it uses a lot of water. If you shower, again, very, very high usage of water. Faucets, and then leaks. That's why it's so important to check for leaks. So that's pretty much the typical home usage there. Now, for Moore Park and that area, and the Oxnard area, about 78% of the water comes from the state water project, about 2% from the Colorado River, and then some is pumped up from the Las Posas Basin. And this is the state water project, the Los Angeles Aqueduct and the California Aqueduct. And then our local groundwater, and then some from the Colorado River Aqueduct. And remember, the first slides, that was Hoover Dam and Lake Mead. And the history of this, the Los Angeles Aqueduct, it's a very interesting story that has been accounted in books and movies, but it's worth paying attention to. If you've read the book Cadillac Desert, it explains all this. And then the California Aqueduct. So all this is what supplies the water to Southern California, because it's very high up here and very low down here. So more people live here, so we need to serve those needs. So we take the water from up here and move it down to Southern California. Now, one thing that we're very concerned about is surface water pollution. And that can be point sources, which are stationary known locations like factories or single pipes, for example, or it can be what we call non-point sources where it's less direct. And that includes runoff that will have fertilizer, pesticides, animal waste, and so forth, and in the winter, road salt deposits. Importantly, they all move downslope and can percolate down and get into our water supply. So here's your non-point sources, runoff from croplands, animal feedlots, for example, rural homes, city streets, or suburban development, runs into the creek, the stream, for example. Point sources that we know, in this case, a wastewater treatment facility or a factory. So all these have the potential to put pollution into the river, which will flow out into the ocean, or some of it will sink into, remember, this is the top of the groundwater, and it will get into the groundwater supply eventually. That's why it's so important to keep track of environmental contaminants and pass laws that, or enact laws that mitigate the amount of pollution. Now, for us in the Southwest, most of it's linked to the Colorado River system, which flows from Colorado, Wyoming, through the southwestern U.S. Now, some of it's exotic streams where the headwaters are in location of water surpluses, but mostly the rivers flow through arid lands to the ocean. The water from the Colorado River system is responsible for Las Vegas, Phoenix, Tucson, Denver, San Diego, and Albuquerque. But as the population in some of these cities, especially Phoenix, for example, continues to rise, we get these growing water crises where the demand for water exceeds the actual supply. So here's the Colorado River basin. You notice all the dams through here. Here's Lake Powell and Glen Canyon Dam. And then flows down. Here's Hoover Dam, Lake Mead, Lake Havasu, where Parker Dam is, for example. Then we withdraw water and take it over here to Southern California. But it also takes care of Phoenix, takes care of Las Vegas, takes care of Tucson. So, Wyoming, Utah, Colorado, New Mexico, Arizona, Nevada, California, they are all using water. And that's even before it gets to Mexico, where there's lots of farmers down here. And then by the time it gets down there, there's none left for the farmers. And that's why Mexico and the U.S. are in a big legal battle over the water usage. And you can see here the stream flow has dramatically decreased because of the fact that all this is being removed by the time it gets down to its delta, former delta. Now, streams vary in stream flow, and as you remove it more than gets replaced, that leads to a drought. Climate change, you have higher temperatures, so evaporation rates increase, there's reduced snowpack, and that's been some of the problems that we've had here in California. Now, you can wait for heavy winters, which we're actually having one this year, but it's better to stress water efficiency and conservation, not use as much. And again, you can see the declining levels here in Lake Mead. So not too often have we had a surplus. Usually we're down here at a deficit. I think this year we're actually going to get a surplus that's going to take us up, but the demand is usually more than we're getting, so it keeps the water levels lower. The other place we get replacement is the Sierra snowpack. But again, it's very, very prone to droughts, and you have years where the snowfall has been decreasing at a very alarming rate. Fortunately, this year we're way above norm, 150% above normal, so that's great for us this year. But other years, like last year and the year before, it was considerably less. So you can see the drought intensity where you get these exceptional droughts, the worst kind, and then um, you just get conditions that are abnormally dry or moderate drought, which through here. But again, these states here rely on the High Plains aquifer, so they're taking out more than is being replaced. And you can go and see this online. This is the North American Drought Monitor, and we're going to look at it through a bunch of different years. But so here's California over here, and here's Texas. So this is 2009, where the exceptional drought here. We weren't quite in the drought conditions here. Then we got heavy rains, so it mitigates. Actually, there was a hurricane, so it mitigated the drought here. We got heavy rains, heavy snowfall, so we were just dry in 2010. But notice in 11, things start to get worse. And at 12, they're really bad, and we're starting to feel the effects of it over here. But here, these states in Georgia, where their reservoirs were disappearing because there just wasn't any rainfall. Then there's a hurricane. They get the moisture they need. But now here in California, this was the worst of our droughts. Starts around 2014. In 2015, severe, the exceptional droughts, D4s. So, notice most of Southern California is in that condition. And then it's back here in the Texas Panhandle and in Oklahoma. Then 16, we're still in a drought. Texas has got moisture, so their droughts are gone. And 18, we've gotten, remember in the winter of 17, we got plenty of rain, so that mitigated our drought conditions. But, it's back in place over here in Texas and the Oklahoma Panhandle. So there's almost hardly any year where some parts of the U.S. aren't in a drought. Okay, so here let's take a break and we'll get to water scarcity. Look at that in a little more depth in the next part.